Most people think that astronomers spend their time looking through telescopes. Now, even though I am working with a lot of astronomical data, I don't do that at all. I work with data that comes from a satellite, Gaia. It's an European space mission. And together with about 400 other people, colleagues across Europe, we are trying to build a multidimensional map of our galaxy from the data collected with this satellite. The scientific community is using the Gaia data to tackle many fundamental questions from the history and evolution of our galaxy and of stars in general to the detection of unusual objects such as hypervelocity stars or exoplanets or brown dwarfs, just to name a few. The data that is transmitted from the satellite is highly compressed and it requires a lot of complex decoding and calibrating on ground. And this is really where my work lies. In general, astronomy is moving towards big and large surveys thanks to advances in technologies, in the detectors, in the electronics and in the computer technologies that we use. What I like about my work is that it's challenging on a daily basis because of all these data that we need to manage, store and process in a timely fashion, and we are always pushed towards new technique, new algorithms, because we want to produce an even better catalog for the next release.
My research interests involve studying of the very early epoch in cosmic history called cosmic dawn. And this is a theoretical epoch at the moment. We don't have direct observations of it, but we hope to observe it in the near future using radio waves, cosmology. So this epoch is very exciting because it hosts the very first stars ever formed in cosmic history and the very first population of black holes. We don't have direct observations or evidence for these structures, but we know that they should exist. And the field I'm studying, called 21 centimeter cosmology, provides a way to probe this epoch directly through radio emission. So there are currently many telescopes being planned, and especially Square Kilometre Array in Australia and South Africa, and even space missions that will look deep into space, trying to detect the universe when it was very young, and included population of the very first stars and the subsequent generation of the very first black holes. So detecting the signal will allow us to probe the masses of the very first black holes and stars, their lifetimes, and also even provide ways on probing dark matter nature, which we don't know what it is, but maybe we will know shortly, and probe the structure of the universe on the very large cosmological scales. I'm most proud of the research that is yet to come, I think. The most exciting things are in the future. Especially now I'm very proud of the series of papers we wrote with brilliant students in Cambridge about the masses of the very first stars. So this is an elusive population that we haven't probed yet directly, but through observing radio photons produced by hydrogen, we might be able to establish the masses of the very first population of stars, because as we show in our papers, they can actually create sizable signatures in this faint radio emission coming from the first billion years. And I think that's very exciting. It's a huge question that is there out in cosmology. My grandmother was an engineer in Kazakhstan, and she studied during Second World War, actually, in a university. And then growing up, I saw her with logarithmic rulers and visited her workplace a couple of times. The influence of my family's careers, I think, had fundamental influence on my own choice, just to demonstrate to me that anything was possible, and was able to find my own passion.
So for those of us who love the outdoors and to travel, we know that Earth has a huge variety of diverse landscapes, from mountains through to river valleys, oceans and beaches. What my research is interested in is what happened in the history of our planet that made it the planet it is today, and such a hospitable place for humans and life to live on. So as astronomers, we're super lucky to live in this era of exoplanet discovery. We now have more than 6,000 planets found around other stars. And so what I'm interested in is really trying to understand what it is that happened in the history of those planets in order to make them the diverse planets that we see out there around other stars. I'm particularly interested in what those planets are made from and how that composition determines the kind of planet that they form. So it's a bit like thinking about making a loaf of bread. We need flour and water, but if you took away the water, then the bread's inedible. And the same if you add extra fat, it becomes a cake. And so we think about the same kind of questions, but in terms of the key elements that form your rocks, things like magnesium, silicon, iron, oxygen, and what proportions you need to form a planet that's like Earth, and a planet that has a geology that's very different to our own. And we're really interested in investigating the processes that lead to diverse planets around stars other than our sun. So I think for discovery and knowledge, we need a diversity of minds, and we need to involve as many people with different perspectives in the conversation as possible. And what's great about the future, particularly of a young field like exoplanet science, is that we really are working in teams involving a lot of different people with very different perspectives, and that's what brings the creativity that's leading to great scientific endeavour.
So I'm a cosmologist. This means that I study the origin and the evolution of the universe, and hopefully even try to work something out about its fate. And for a long time, my science, cosmology, was a very data-starved science. It was very speculative, lots and lots of theories. But in the past 20 years, it's been possible to get data from different times in the universe. The very earliest light we can see is a baby picture of the universe. And then we can look at how galaxies form and evolve, and that tells you how the universe is evolving over time. And by studying the connection between our theoretical understanding and the data we observe, we can try to piece together a story of the universe. This has allowed us to answer all these questions that people have had since the beginning of history, but it's also opened up a lot of new questions that we're now trying to answer. So in my field, there are quite a few big problems that we are working on solving. And the one that I'm most excited about, where I think we do have a chance of solving it within the next decade, is the problem of dark matter. Basically, 80% of the matter in the universe, we observe it through its gravitational interaction, but we don't know what particle it consists of. And theorists are very clever, and they've come up with many, many hypotheses for what this particle could be. And so we are looking everywhere for what kind of dark matter particle could exist. And I personally feel like looking up at the sky and also working in laboratory experiments here on Earth, working together and combining those two approaches, we can work out what is the dark matter, hopefully within the next decade. Historically, it has been the case that all the women who wanted to be in academia and to do science have not necessarily got the encouragement to do that. And they have also encountered systemic barriers to their participation. What this means is that historically we have lost out on a lot of perspectives and talent that could have been directed towards solving all the thorny questions that we have in our field today. Going forward, I personally want every young person, regardless of their gender, to be encouraged to fulfill their potential. And if a career in doing research in astronomy is what they want to do, they should have the door open to them to do that. And part of that requires themselves to see themselves in the generation that's older, so that they can feel like they have a place and they belong. So for me, representation is a key part of solving that historic underrepresentation. More broadly, it's shown that diverse viewpoints, diverse talents actually contribute to better outcomes. So diverse teams do better, and we should benefit from that diversity.
I'm particularly interested in the origins of things, and in my case, the origin of stars and planets. And we have wonderful images, such as the one behind me at the moment, showing the first few million years of stars' lives when they're condensing out of the dense and dusty gas, which is their sort of cradle. But for me, you could almost describe what I do as a kind of environmental science of planet formation, because for a star which is trying to form planets in an environment, as you see behind you, there are a lot of environmental risks out there, particularly huge quantities of ultraviolet radiation coming from nearby, much more massive stars. And one of the things that I'm very interested in is working out how planets can possibly form in environments like this, which are actually very common throughout the Milky Way. Now, I'm actually a theorist, so although I love images like this, I don't use telescopes directly. I'm using the equations of maths and physics to derive models for how the disks in which the planets are forming are being literally fried by the ultraviolet radiation coming from the hot stars. And this is actually an essential part of astronomy. It's not just taking the astronomical images, it's also being able to interpret them. So you do need theorists who are using the laws of maths and physics to be able to relate what we think is going on in a system to the beautiful sort of coffee table type image that you see. And I think most of my career has been devoted to these kinds of problems. I think we've made terrific strides in recent decades. I think there are many more women in positions of authority and power within the astronomical community, and that's very good for new generations seeing that and taking it for granted. I also think there's a much wider acceptance that work-life balance is something which is important for everybody. It's not anymore seen as a women's problem. It's something that men and women have to grapple with as they balance family commitments against science. I think perhaps for us is the sense that we're perhaps not seeing all the women who are coming into our subject that we should be, because we believe there are probably things that are putting them off while they're still in the school system, age 15, 16, so that the fraction of women who are studying for maths and physics A-level is low, and of course that then has an impact on our community. So we do a lot in terms of public outreach, going out into schools and trying to make the general message that science is for everyone. Gender isn't relevant to the universe itself, of course, but in reality, the way that we do science does depend on the human interactions of the community that produce the science. And of course, there are many gendered assumptions which may or may not get in the way of our main business. Our aim is always to focus on the abstract questions that we are facing.